Right, let's look at this then. So I asked you to work out, so now, so let's come back to it, because I think I asked you to work out these two as well. So this is the basic stuff. Now, let's rattle through these relatively quickly, because I actually push you on to the harder stuff, okay? So we've got the sector, and we are being asked to find the arc length. So, understand? R is that bit, which is a fraction of what? The circumference, yeah? So which formula do I need? Circumference equals
pi d.
pi d, okay? Or 2 pi r, yeah?
Yeah.
What's 6?
The radius.
Okay, so that's r, right? So the circumference is going to do 2 times pi times 6, okay? Which, by the way, if you sum it slightly, is going to be, I'm going to do 2 times 6 is 12 times pi. Now, just out of interest, this is for those of you that think, yeah, I can cope with that. When it says give your answer in terms of pi, it means do it like that, not turn pi into a decimal. All right? But anyway, let's, we haven't finished yet. Because what do we need to do? Not, well, yeah, I'm not going to do that yet. What's the next bit we would do? Well, the angle's 60, so I don't actually need to. What do I need to know? I need to know how many of those fit in the entire circle, don't I? So it's 360 degrees divided by 60 degrees, and that is 6. Well, I know that the arc is this value divided by 6, yeah?
Yeah.
So the arc is 12 pi divided by 6, which is, well, if I tell you 2 pi, are you okay with that? Now, this is the new thing today. That is my answer in terms of pi. But we're not going to do that. We're going to work it out as a decimal. What is 2 times pi? 6.3. And it's in centimetres. So just a thing for your notes, this is the answer in terms of pi. So that might be something new to you, but it actually makes things a little bit easier, I think, to leave it in terms of pi. But that might, the reason why I've not really focused much on that is because it probably won't be a thing e-assessment.
If that's the question and we answer, some of us probably answered before we even.
So if the question says give your answer in terms of pi and you write that, it's mark. Alright? If it says round your number to the nearest decimal place and you leave it as 2 pi, you'll lose a mark. So if it doesn't ask you at all, you can leave it in either of those ones. Up to you. Yeah? In fact, I would expect maybe the top students that are rattling through things really quickly, unless it tells them otherwise, just to leave it in terms of pi. Because what don't you have to do with that number that you do here? Round it, yeah? No rounding necessary, therefore less chance of mistake. Good with that question? Do you get that right, Luke? Do you know why? So what calculation did you do to get that?
I obviously did something.
Maybe I can check in a minute. Let's have a look at question 5 then. Alright, we now want to know the area of the sector, so that's the whole space, so what formula do I use?
A equals pi r squared.
Alright, that's the one I'm going to use. What's R in this case? R is 11 meters. So the area of the entire circle would be pi times 11 squared. Now, do you notice this one, it says 3 significant figures? But this one I'm not leaving in terms of pi. But what I could do is I could say it's 121 pi. Are you okay with that for the moment? And I'm going to do it afterwards. Or would you rather keep it what we've been doing before? Let's do it. Tell me what 121 times pi is.
Mm.
380. 380.13. I want 3 significant figures, so I need at least 4. And I'm okay with 5. Alright, what's the fraction of the entire circle? It's 360 degrees divided by 200, and you get 1.8, yeah? Exactly, or?
Yeah.
So then the sector area is going to be 380.13 divided by 1.8, and what do you get? 1/8. So to 3 significant figures, the area would be 200. What are the units of it? Square meters. Don't forget that, because in an NYPE assessment, that actually is an important aspect to it. Yeah? Because we have, even in GCSE questions like this, they expect you to put the unit. Well, this one would be considered easier because they've given you it. But in the NYPE, part of your communication is to use those units. So if it doesn't give you it in the answers. All right, back to the perimeter one then. So I said to you, the perimeter is all the way around. So it's the arc plus 2 lots of the radius, which is the bit people forget. So let's do the arc first. How do I work out the arc again? It's a fraction of the circumference. So which formula do I use? C equals 2 pi r. R is 5.2 centimetres. So the entire circumference would be 2 times pi times 5.2, which is? Just check. I don't know, so you have to check. 32.6, yeah? You have to put that. 32.6 centimetres. All right. What do I have to do now, though? That's the entire circle. So I only want the little bit of it, yeah? So I've got to work out the fraction. So it's going to be 360 divided by 80 equals 1.5? 1.4? 4. So then we do 32.6 centimetres divided by 4.5 gives me 7.24. 4 again.
Yeah.
Okay. We only want 3 significant figures, so 4 is good. That's just the arc then at the moment. So the perimeter is going to be arc, 7.244. So imagine I am going to be stood here. The perimeter is walking all the way around, so I walk 7.244. Then I walk plus 5.2, and I'm here, and then I have to walk plus another 5.2. So if I add all that together, 17.644, yeah? All right? So the perimeter to three significant figures is 76. And the units?
7.
17. Yeah? What did you do?
I thought that that stuff because it was like radius times 2, so I did like 5 times 2. And
Oh, good. Well, that's what I basically did there. Yeah. No, but that is 5.2 times 2. That's that bit. I think what you did was divided the whole thing by 4.5. You added them first and then divided. I think that, so basically, yeah, there's your mistake. So this whole bit here was just the arc bit. Should be just that, yeah? This bit down here was that gets separated, so it's not the dividing. Yeah. Yeah, it's right. So that's the basics. That was our first example of a slightly more complex one, just that one little step. What comes next? Well, this is where we start combining things together. Now, this is a very common problem, regardless of what shape you use. All right, is the area of the shaded region. All right. Any ideas? Just looking at the picture, what do you think is the method? Okay. Quarter of a circle, half a circle, yeah. How do you think you're going to work out the area of just the shaded bit then, using that information? Well, we want the area actually. There you go. Did you all catch that? That's the normal way. When you've got these, work out the shaded region, what we normally have to do, all right? So the shaded area is normally the large area minus the small area. That makes sense? So if I were to just, for instance, if I shade in kind of the whole thing, yeah? Yeah, if I work out the large area, I basically work out all of that, yeah? That's the large area. All right? Actually, I need to do it differently. So, probably could stop the slide and open boring to watch. No. So, this is the process, this is what we're going to do. I wouldn't shade yours in like that, but I'm just going to show you. So, if I work out the large shaded area, the large shaded area is, that Alistair already told us it's how much of a circle? It's a quarter, and then the small area is, yeah, half a circle, semicircle. Now, if I then to that circle, that area, if I subtract that area, I'm left with just the shaded area. And that's actually true for all shapes. Like, they quite often will do this with rectangles, or triangles, or pentagons, or anything. It's like, have you seen kind of questions along the lines of, here's a circle, like, here's a ring shape, work out the area of the ring, yeah? How do you work out the area of a ring? Big circle, subtract the small circle, yeah? Here's a square or rectangle, and let's put a hole in it, another rectangle. How do you work out the area of the shaded bit? Big one, take away the small one. Yeah? I could do it with any shape. Area of a triangle, area of a circle. Work out the area of the triangle, subtract the area of the circle. Now you need to think of it instead of a hole in it, you think of the two shapes. So that's the process, that's what we're going to be doing. So now you know that, you think you can work out stuff. So we just got to work out, well, what information do I need to work out the area of that circle? The quarter of a circle. The area of, there's no such thing as an area of an arc. No, but you're mixing the area and the arc thing. The arc is just that distance, yeah? Does that give me any area? It's not. Right? That's just the length of the line. How do you work out the area of what we've just been doing? What do you need first? The whole circle first. What's the area of the entire circle? The big one. That's the angle. What's the formula for the area of the circle? Pi r squared. But here's the question, what's r in the circle, big one? 10, look, here it is. So r is 10, yeah? So can you work out the area of the circle that would be that big one? Well, we now do that. What we've got, yeah? So that's what I was just saying to do. Is it the same circle as before? So this one, look, is that quarter of a circle is actually quarter of a really large circle, yeah? So the area of this big circle is actually 314.14. And we take that and divide by 4 and we get the area of the quarter of a circle is that. Yeah? What do I need? Well, I need to now know the area of this smaller circle, yeah? What's the area of the smaller circle? This area equals pi r squared. Yeah? What's r of that circle? 5 centimeters. Did you get that, Vic? Why is it 5 and not 10 this time? Yeah, because remember this circle has a centre and 10 is the whole thing, so this one is actually 5 centimetres. So we go 5 squared is, so we're going to do pi times 5 squared, which is 25 times pi. What did you get? 5 squared is 25, yeah? Not 10. Just in case. Hey? What did you get?
78.5.
Pardon?
78.
What I worked out, yeah, was 25 times pi. Okay, which should give you the same answer. Okay.
Oh.
What was it?
78.
78.53. Oh, I didn't say you were wrong, I just noticed you were. I didn't say it was wrong, I just thought, let's go through it. Now, you will notice that that number is actually the same as the quarter of the area. Now, this is one of those interesting things. Okay? Why they've done it. All right? How much of that do we want, though? Half of it. So we're going to do 78.53 divided by 2 gives you 39.2. Exactly. 65. Well, that's important, isn't it? Because we're going to do the big quarter minus that half. So we're going to do 78.53 minus 39.2. I'm going to round it to 27. So the shaded area is the result of that. What do we get? $39.26. So 27 then, yeah? And you'll notice that that is half of. So you'll notice if we do this, this is actually half of that area. And that's not something you have to remember, but some people will, and therefore it'll be a really good question to do. We don't have to. The area is 39.27 square centimetres, so that is the final answer. So just to recap, the process has been, when you work out a shaded region like this, you work out the shape that's the main thing. So the quarter of a circle was the big one. The cutout is actually a smaller semicircle. So if we work out the big one, subtract the small one, we're left with the shaded region.
But what if the big one be the same size? If it's half. 39.27.
So this shaded is the same as that.
Oh.
This region and this region are the same size. That's an interesting result. We don't need to know that, but it's an interesting result, I think, for a question like this. Yeah? That's the kind of thing. For people that work a lot with circles, they would know that, and therefore it can simplify their calculations. Right? Now, following on that process then, is this question. Well, it's actually easier, right? What are the two shapes now?
Most of a rectangle.
So it's not well, what are the two shapes? Not most of a rectangle, but an entire rectangle. So the large shape is the rectangle, and the smaller shape is the semicircle. So you have got to work out the percentage thing. We will do at the end if we've got time. But what is the process to work out the shaded area? You are going to work out. You are going to work out the area of the rectangle. Yeah, you've got formula there. You've got your formula there. And you are going to work out the area of a circle, and you only need half of it. Yeah? So the shaded region is rectangle minus circle, but divided by 2. You can probably go through the whole thing. So,
So we have to do
for what shape? Yes. Area is pi r squared, always. It doesn't change. What's r of the circle? How do you know that? Yeah, good. This side here is that, so we know the radius is 6 centimeters. There's a piece of information. Right? So it's work out the rectangle, you know a formula, it's in your formula booklet. Make fun of it. Area of a circle, divided by 2, we can do loads on that. You were asking a question?
You have to,
Divide what? The whole answer? No. Which bit needs to be divided by 2? Just so. That was the thing that we did on before, wasn't it? So have we got the area of the rectangle? Did you work it out? It's just 15 times 12. Length times width, 15 times 12. What do you get as the area of the rectangle? 180. Square centimetres. And we only want half the circle, so a circle's area is pi r squared. What did we say r was? 6. So you should have 6 squared. So the area of the entire circle is 36 times pi. What do you get for that?
Why is it half of a circle?
Got half a circle.
Samsung.
It's not half of a semicircle, it's half a circle.
6. Why do you have 6?
So the radius of a circle is the length from the middle to the outside of the circle. I know this length is 12, therefore the whole thing is 12, therefore half of it is 6. Sorry, and you say 113.07. So that's the area of the entire circle, but we only want half the circle, so that would be 113.097 divided by 2, and you get
56.
56.55. So, up here, look, this shaded region is going to be the 180 for the entire rectangle, minus the value for this is the 56.55. Yeah? This area is 56.55 square centimetres. This whole area is 180 square centimetres. So the area of the shaded region is that. And what do you get for that? 123.35? 2? Okay. I'll leave it like that. So that's the area of the shade. Now, just to finish this up, and then the question says, calculate the percentage of the rectangle that is shaded. So this is a pre-required knowledge. This is something you should already have in your mock-up, because I've done it with M1s and I don't know. So I know you've done it, it might be useful, but I know you've done it, you don't remember it. So just as a recap, percentage is a fraction that you then turn out 100, and we do it by doing this. It's the percentage of the area of the rectangle that is shaded. So how much is shaded? 123.35 out of 180. Times that by 100 to give me the percentage. What do you get? So it's 123.35 out of 180, 68.5%. Does that make sense? Quite a bit more than a half? Makes sense. So that's the final bit, the percentage finish. And you'll quite often be asked as a last off thing, what is the percentage? Now, remember that, how do you work out your percentage test score? If you scored 55 out of 60, you do 65 divided by 60 times 100, it's the same thing. 123 out of 180, bang. Right, I'm not setting any homework because we'll start the time. But make sure if there's anything within that was in the review list, wasn't it, Alistair? In last words. But that's in your mock. If there's anything you don't understand, take time, come soon.